had a question about finding a line through a given point with a given slope. The situation in general is this. I'll do a specific example, but let's say you have a given point here, and the given slope is m, and this is any point xy. Then I can say that xy is on the line through the given point if what? And only if. You can say if and only if. Well, whatever the given point is, you got some run and some rise out here to the any whole point xy. If the rise over run from the given point to xy is equal to the given slope. Okay, in this case, if the given slope is m, then the rise over the run from whatever the given point is out to xy has to equal m. Now that doesn't necessarily seem all that helpful, but let's apply it. Okay, so what if the given point is, let me go back here, I'm going to use the point in the question that we had, and that was 1, -1 with a slope of -2/3. So the given point is 1, -1. Given slope is -2/3. So now we have the point 1, -1, and we have the point xy, and the slope is -2/3. Okay, so the slope from 1, -1 to xy is -2/3. So how do we write this as an equation? Well, what's the slope from 1, -1 to xy? Rise over run is what? What's the rise from -1 to y? That's going to be y minus -1. The run is going to be x minus 1, and that should equal -2/3. So, well, right here we've got an equation we can solve for y. And that'll give you the slope-intercept form of the straight line. Slope from 1, -1 to xy equals the given slope -2/3. We can solve that. The equation becomes y plus 1 over x minus 1 equals -2/3. Multiply both sides by x minus 1, we get y plus 1 equals -2/3 of x minus 1. We can distribute the -2/3 through here. We get, I'll leave the 1 on this side. I was tempted to add it while I was distributing, but okay, we have -2/3 x plus 2/3, so that y equals -2/3 x plus 2/3 and we're going to subtract the 1 here, minus 1. So y is negative 2/3 x minus 1/3. Now that's the slope-intercept form of the equation. What if we want the standard form? Standard form is ax plus by equals 1. To get the standard form, we're going to multiply through by 3. So we're going to get 3y equals negative 2x minus 1. And multiply both sides by 3. Clear the denominators. And then we add 2x to both sides. We get 2x plus 3y equals negative 1. And this is a general form. Now I use the word standard here. I should have said general form. Got my terminology around, mixed around a little bit, but here's the general form of the same equation. Here's the slope-intercept form, and we could also put the thing in point-slope form, which would be rather easy given this situation. To be complete here, I also have to mention the point-slope form. It's the same situation. You're given slope m, your given point we'll call x1, y1, and the point that's going to be on the line is, again, xy. So doing the same thing we did here, the reasoning is exactly the same. The run is x minus x1. The rise is y minus y1. So what we get is rise over run equals y minus y1 divided by x minus x1, and that equals your slope, which is m. And then we just multiply through by x minus x1, and we get and what we get is going to be y minus y1 equals m times x minus x1. And this is called the famous point-slope form. Okay? If you understand this reasoning, you don't really need to memorize this form. All this form says is basically that the rise over the run equals m. And then we multiply through by the run to confuse things a little bit. That's a perfectly good form. It works perfectly well to get you the equation, and if you want to use it, I'm not going to object, but I think that this is more direct because it says something. I mean, this says something too, but this says it more simply. And this whole idea of finding the slope from the given point out to xy and setting it equal to the given slope is in many ways more efficient and tells you more about what's going on. It gives you a better picture of what the equation of the line actually means. Still, if you want to use that form, I won't object in the least.